Marshall and Rick. We want to continue from the objects-oriented data model. And the contents we shall be discussing about the basic concepts, the types of objects-oriented database model, and also we as well look at the features of object-oriented data model and also some examples of that. And we'll consider the advantages and the disadvantages. Then that will bring the lecture into conclusion. So the basic concepts. The real-world problems are closely represented through the object-oriented model. And in this type of model, both the data and relationships are represented in a single structure called an object. So in other words, object is just a single structure in an object-oriented data model. So we can store audio, video, images in this database, but it is advised not to store in the relational database. So in this model, the attribute describes the properties of an object. Object-oriented data model is based upon real-world situations. These situations are represented as objects with different attributes. Objects could also be regarded as an entity. So all these objects have a multiple relationship between them. And that is why storing audio or images or videos in this database will be a problem as a result of what the relationships among them. What are the types of object-based data model? We have two of them. One is the entity relationship model, ER data model. It's a type of object-oriented data model that is very important in data modeling, which forms the basis for all the designs in the database world. Object-oriented data model is the second type of object-based data model. And in this type of model, it's designed by mapping between the entities, which describes the state of each entity and the tasks performed by them. Type of object-based data model. So still looking at the entity relationship data model and object-oriented data model. In entity relation data model, entity relationship data model is one of the important data model which forms the basis for all the other designs in the database world. It defines the mapping between the entities in database. Object-oriented data model, along with the mapping between the entities, describe the states of each entity and the tasks performed by them. For instance, if you come to university database, we have a computer science department. So in computer science department, you could have various entities such as the academic staff, the students could refer as an entity. Also in the in terms of the staff in the department, we could have academic staff, we could have a non-academic staff. And even in non-academic staff, we could also have junior staff and the senior staff. So these are the entities in the computer science department database. All right. Entity relationship model is based on the notion of a real-world entities. Why do we call it real-world entities? Because it's something that is very common, a very thing that is just real and common. And the relationship among them. Why formulating real-world scenario into database model? The entity relationship model creates entity sets, relationship sets, general attributes, and constraints. Okay, the ER model is best used for the conceptual design of the database. The ER model is based on their entities and their attributes, then the relationship among them. So I've given an example, I'll describe what an entity is. Let me repeat again. When you come to university database, we have different entities. We could have computer science department as an entity. We could have other things as a part of the entity. Okay, so then attribute is when you come, for instance, computer science department, you could have different relations like student relation. Another student relation could have attributes such as student course, student's name, student sex, student's matric number. These are the attributes of the student entities. And when we talk of relationship, is the what exists between the students and also a staff relation. We call it a relationship, and this could also be, addressed using a key or integrity relationship, such as primary key, composite key, or secondary key, as the case may be. So look at the example here, entities. Hello?
Hello? Hello, sir.
Yes?
I'm at the gate now, but I'm knocking. My sister has not come out yet.
Okay, let me call her.
Okay.
Hello, in on the yard.
Hello?
Hello, ask me on the yard. General Mujara Fura is up there now. Head on the gate. I did a question. My head checking. You people should just wait. She went to one of our neighbor house, so she's coming now. All right, we are discussing about the entities. So an entity in an entity relation model is a real-world entity having properties called attributes. Okay, so an attribute, entity could have more than one attribute. So from the here, this diagram of an ER model, we could see that we have just two entities. One of the each of the entities having two attributes. So entity could have three attributes, could have four attributes, or more than that. And also, we need to note that each of the entities also have an established relationship among them. So every attribute is defined by each set of values called the domain. For example, in a school database, a student is considered as an entity. Student has various attributes like name, age, class. So when we talk about relationship, the logical is just the logical associations among entities. So relationships are mapped with entities in various ways. So mapping cardinality of defines the number of associations between two entities. Okay, so we'll be looking at what is called cardinality. Cardinality just number of entity, number of association that exists between two entities. So another example, we want to look at the example now. Consider the example above. It maps entity like students, lecturer, subjects, and marks with each other to form relation among them. So it also lists attributes of each object. Entity relationship model represents all these entities, attributes, and relationship in the form of pictures to make the developers understand the system better. So a simple ER diagram for above example can be drawn as below, as we are going to see in the subsequent slide. So are you able to understand what are the entities involved? What are its attributes and their relations that we are discussing better here? Yes, it is clear, clean and clear what a student's database looks like, okay? In the below diagram, entities or real-world objects are represented in a rectangular box, okay? So you can discover we have like 4 different rectangular boxes. We have student entity, class entity, lecturer entities, and subject entities, all right? Okay, their attributes are represented in ovals. So the primary key of entities are underlined. Okay, so all the over, for instance, in a student entity, we have 4 attributes, which are the student ID, student name, address, and class ID. Okay, then all the entities are mapped using a diamond. Okay, we map, create a relationship, you understand, in between the entities using a diamond. For instance, we have the mapping of students and lecturers entity. Teacher is just a map, serve as a map. So we have like lecturer teaches students, all right? Then a mapping of a lecturer and subject entities, we have also teaches, okay? We have lecturer teaches subjects, all right? Then the mapping of class entity and subject entity, we have subjects being class has subjects, all right? Then in the mapping of students and class entity also, we have students attends class, okay? So in subject entity also, we have 3 attributes: class ID, subject ID, and subject name. Okay, so this is one of the methods of representing ER model. There are many different forms of representation. More details of this model can be defined in data articles. Okay, so basically, entity relationship model is a graphical representation of a real-world object with these attributes and relationship. Their attributes and relationship. So it makes the system easily understandable. So this model is considered as a top-down approach of designing a requirement. So what are the advantages of ER model? Number 1, it makes the requirements simple and easily understood, understandable by representing a simple diagram. Number 2, one can convert ER diagram into record based on data model easily. Number 3, it is easy to understand ER diagram. What are the downside of it? We have some limitation. Number 1, no standard notations are available in ER diagram. So there is a great flexibility in the notation. It all depends upon the designer, how he draws it. It is meant to high-level design. So we cannot simply simplify it for low-level design like coding. Okay, so these are the downside. Next, we want to discuss the object-oriented data model. So we have done with the entity relation data model. We want to look at the object-oriented data model. This data model is another method of presenting real-world objects. Okay. So it's related functionality together and allows inheriting its functionality to other related subgroups. So let's consider an employee database, for instance, to understand this model better. So in this database, we have different types of employees, okay? So we have engineer, we have accountants, we have manager, we have clerk. All those listed are employees. So, but all these employees belong to a person group. So person can have different attributes like name, address, age, and phone number. What do we do if we want to date a person's address and phone number? We write two separate procedures. SP gate address and SP gate phone number. Okay, that is S stand for separate, P stand for procedure. Okay, all right. So, for instance, we have looking at that example, we discover that what about all the employees above? So they too have all the attributes what a person has. Okay, so one of the all the employee has the same attributes, for instance, because of course they are being represented by an individual. So in addition to that, they have their employee ID. Okay, so what of course each of the employee must have a unique identifier as a member of the company, you know, or as an employee. So that employee ID serves as what? As a primary key, which can uniquely identify each of the employee. So also we have employee type. That is where we have different types. We have engineer, just as we look at the previous, we have engineer, we have accountant, we have manager, and we have a clerk. And also we have department ID. In which of these department, which of the department does each of these employee type works in? So all these attributes is actually used to identify them in the organization and their department. So we have to retrieve their department details, and hence we have a separate procedure for get department detail procedure. So currently say we need to have only these attributes and functionality. So we have shape, cycle, rectangle, and triangle. So just using as an example. So get area, get perimeter, get the area of a circle, get the area of a rectangle, and get area of a triangle. Of course, to get the area, we compute, we have a base and height. We have in rectangle, we have length and breadth. In circle, we have a center and radius. Okay. So see an example. So shape, for instance, circle, rectangle, triangle are all objects in this model. Circle has the attribute center and radius. Okay. Rectangle has the attributes length and breadth. Triangle has the attributes base and height. The object circle, rectangle, and triangle inherits from the object's shape. Okay. All right. So when we have objects shape as an object, so from the shape we will now drive circle, rectangle, and triangle. Okay. So objects that share similar characteristics are grouped in classes. Okay, therefore, a class is a collection of a similar objects with attributes and methods. In this model, two or more objects are connected with the help of links. So we use this link to relate objects. It is explained in the below example. So we have employee, we have departments, we have attributes, name, job title, phone number, salary, department ID, and the method we see we get higher, change number. So in the same thing applicable in the department entity, we have attributes such as department ID, we have a department name, they have methods, they have change departments. Okay. So see on the example of the objects oriented data model. So there are two objects in this above example. We have employee and we have department. So each object data and relationships are contained in a single unit. The attributes are name, job title. Methods are used to perform the operation with the help of attributes. So the two objects are connected through a common attribute, department ID, and communication between these two will be done with the help of an ID. So we are going to be looking at the features of object-oriented data model. Okay, so the features of object-oriented data model is not different from the feature of a normal object-oriented database, okay, or object-oriented programming. So which I believe you have done a Java object-based programming like Java, okay? So we start with objects. Object, what is objects? The real-world entities and situations are represented as an object in the object-oriented data model, okay? And objects, apart from object, we have also abstraction. Abstraction. What is an abstraction? Abstraction is the procedure of representing only the essential data features for the needed functionality. So the process selects vital information while unnecessary information stays hidden. So abstraction helps to reduce the complexity of the model data and allow reusability. Okay, so what it all stands for, it means that when we talk of abstraction, it's just a way of hiding non-essential information, you understand, and select and selection of the vital information. So, and the purpose of abstraction is to help reduce the complexity of the modeled data, and also it helps to allow reusability of the information. Then next is a class. What is a class? Class. Similar attributes and methods are grouped together using a class. So an object can be called as an instance of the class. An object can be called an instance of the class. Then we have inheritance. A new Ella? Yeah. Um, okay, you can go ahead. All right. We are discussing about inheritance. We said a new class can be derived from the original class. So the derived class contains attributes and methods of the original class as well as its own. So in this case, in this scenario, we call it an inheritance, the inherited class. You know, we inherited attributes from the derived class. Next, we will be looking at the object's identity. So object identity, what is object identity? So it provides a unique identity to each independent object stored in a database. This unique identity is implemented via a unique system-generated object identifier. Okay. So abstraction. So in more detail, want to look at abstractions. So what are the characteristics or the features of abstraction? Number one, It is the process of identifying the essential aspects of an entity and ignoring the unimportant properties, okay? Number two, it has two fundamentals, which are encapsulation and data hiding, okay? Encapsulation and data hiding. So these two fundamentals are actually different. You know, sometimes we may confuse the data hiding from encapsulation, and we need to understand the difference between each of these fundamentals, okay? So let me just briefly explain. Number one, the concept of encapsulation. When we talk of encapsulation, it means that an object contains both data structure and a set of operations that can be used to manipulate it, okay? So it's just two things. The object, it has the data structure and also the set of operation, the methods that can be used to manipulate the data structure. Example, we have defined class employee, type tuple. We have name, string, date of birth, birth date, or rather, we have date data type, salary, we use floating number data type, then operation creates M, uses employee data type. We have destroy M, use a boolean, okay, and end employee. So that just is a snippet of encapsulation. So in details, we want to distinguish between the data hiding and encapsulation. Number one, what are the key differences? Number one, encapsulation deals with the hiding the complexity of the program. And on the other hand, data hiding deals with the security of the data in the program. Number two, encapsulation focuses on wrapping. You know, wrapping, just encapsulating. It means encapsulating. So it's focused on wrapping the complex data in order to present a simpler view for the user. So on the other hand, data hiding focuses on restricting the use of data, intending to assure data security, okay? So instead of restricting, instead of hiding or wrapping, then what the data hiding does is to restrict the use of data. Okay. Number three, and what is the purpose of restricting? To assure the data security. So number three, in encapsulation, data can be public or private, but in data hiding, data must be what? Private only because of the security. Number four, data hiding is a process as well as a technique, whereas encapsulation is a sub-process in data hiding. Next class. What is class? What are the features of classes? Okay. Class is used to define the set of simpler objects, objects with the similar attributes, and message are grouped together to form the class. We have branch, a relation, we have attributes under the blank branch entity. We have branch number, we have city, we have pseudocode for that branch. Then the method, we have print method, we have get post code method. So inheritance. So inheritance, staff is also a subclass of a superclass person. We have class person, you have staff inherited from the person, okay? Then they are superclass, they are called superclass. We have manager, we have sales staffs, we have a subclasses as part of inheritance. Example. Since all employees inherit the attributes and functionality of a person, use those features in employee. But the way you do that, we group the features, the person into class. Hence, a class has all the attributes and functionalities. For example, we will create a person class and it will have name, address, age, and phone as its attributes. And SP, that is separate procedure, gets address as separate procedure, gets phone number as procedures in it. So the values These attributes at any instance of time are objects. All right, so we have John, Troy, 25, 24, 5, that is postcode. Then separate procedure to get address. We have for John, we have separate procedure to get phone number for John and forms on person objects. So these are the example. So this is just the translation of what we have just looked at. Class, we have a personal employee. So, okay. Person, we have name as an attribute, address, age, phone number, and we have method. Separate procedure, get address, and separate procedure, get phone number, okay? Then we also have a person, John as an attribute is a person that inherited. Then we have John, address, Troy, age 25. We have phone 2455535545. So Gates address, John address, Troy. Gates phone number, of course. So the procedure to get the address, Troy, and the procedure gets the phone number. Okay, so similar thing happens here. The same person, we have Matthew, Fraser Town as an address. We have 28 as age. We have 564-5677 as a phone number. Also, we have another employee. Okay, we have persons, method. We have employee ID, employee type. We have department ID. Okay, and get department details. Okay, in this case, this method will get the details such as John, the name, and also the manufacturer. In the case of this, we have John and then Matthew. Okay, the employee ID for John, we have 12-12-1, and Matthew also have 12-12-1. Okay, in employee type, we have engineer. In the department ID, we have 100. So from the above, here we can observe that the features of person are available only if other class is inherited from it. So it will be a black box to any other classes. So these features of this model is called encapsulation. It binds the features in one class and hides it from other classes. It is only visible to its objects and any inherited class. What are the advantages? Because of its inheritance properties, we can reuse. So we are discussing an advantage of object-oriented data model. So we can reuse the attributes of functionality, okay? And it reduces the cost of maintaining the same data multiple times. Also, all these objects are encapsulated and there is no fear being misused by other objects. Hence, it reduces the overhead and maintenance costs. Number two, because of the above features, it becomes more flexible in the case of any changes. Codes are reused because of inheritance. So since each class binds its attributes and its functionality, it is same as representing real-world objects. We can see each object as a real entity, hence it is more understandable. Inheritance promotes data integrity. Visual representation includes semantic contents. What are the drawbacks? The downside. So it is not widely developed and complex to use. It is to use it in the database system. So hence, it is not accepted by the users. It is an approach for solving the requirements. It is not a technology, hence, it fails to put it in the database management system. It is a complex navigation system and it also slows development of a standard. All right, in conclusion, we have looked at the object database model, the object-oriented and the entity relationship data model. So in this aspect, we have considered the menus, which can be created, accessed, and updated in the same way as the data. All right, furthermore, so a basic set of menu is generated from the database schemas and made available to the users for the purpose of the answering a simple query. So a prototype of the object with the data model has been implemented and used to model an application domain. Thank you for listening.